Hey, what's up everyone? Jason Turley here, back with another video. We're once again on everyone's favorite CTF website, picoCTF. And today we're going to be looking at picoCTF 2024, which recently completed a couple weeks ago. And we're in the general skills section of challenges. And we're just going to grind through and knock out a few of these. So getting started, we're going to look at Super SSH, Super Secure Shell, and see what this is all about. The description reads, using a secure shell is going to be pretty important. Can you SSH as CTF player to this host name, titan.picoctf.net, on this port 54080 to get the flag. You'll also need their password, which is this like random jumble of numbers and letters. If asked, accept the fingerprint with yes. If your device doesn't have a shell, you can use the picoCTF web shell, and they give you a link to that here. I showcased how to use this in a different video from about a month ago, so check that out if you're not familiar. And then if you're not sure what a shell is, check out the picoCTF primer here, which is also a very good resource just in general for computer security, programming, and capture the flags. So I won't go through all of this. If you guys have seen any of my videos, you're already familiar with what a shell is. I call it a terminal, but you can use it interchangeably, right? So it's somewhere you can enter commands, and there are different shells. So if I come over here and open up my terminal, I can cat out etc shells, and we can look at all the different shells available on my system. I think it's echo $$. No. Echo $shell. Yeah, if you echo out $shell, which is your environment variable, it will tell you what shell you're currently using. And then you can poke and move between the different shells as you see fit. Most people are very familiar with bash, so just hitting bash will put you in the bash shell. Okay, so that did not update my environment variable, but I am in the bash shell. PS. There we go. If I run a PS, we see that I am in the bash shell, and I've started out as the Z shell. If I do echo $shell level, we'll see I'm 2 shells deep. If I exit out of bash, run another PS, I'm back in Z shell. So echo $shell level, I'm back in my original Z shell. So not pertinent, not particular to the challenge at all, just a fun little bit of trivia. So let's get started. Let's log in to this host. How do we specify a port? So tech lowercase p, you can specify a different port. By default, SSH will use port 22, because that is the default port that the service runs on. Port 54080. And that's it. So we specified, make this nice and big. We specified the command we're using, secure shell, which is a remote authentication protocol that's encrypted. Our username, CTF player, the host name, titan.picoctf.net, and then the port that we want to run this on, 54080. Smash the enter key, and we're going to get this banner, we're going to get this warning. The authenticity of this host, right, where we're trying to connect, can't be established. We get some message about a fingerprint being SHA-256. The key is not known. So we've never logged into this server before. We've never accessed this host. So our computer is just saying, are you sure you want to do this? So we can hit yes. And then it permanently added this entry into the list of known hosts. And now it wants us to enter the password. So I'm going to come back here, grab this password, and slam it in. And that was pretty simple. We see welcome CTF player, here's your flag, picoCTF, secure connection, and then the random bit at the end. And then our connection is immediately closed. Okay, I was playing around with this a little bit more and seeing if we can connect with secure shell and just get the flag as the output. So my new command is SSH secure shell with a tech Q, which stands for quiet, suppress some of that noise and that output that we get normally. And then once again, the connection line, the username, at the host name, and then this port. Grep out just for the string pico, because that's what our flag starts with, picoCTF. And then we'll use the command cut to filter out just the actual flag. So now I want to hit enter and then paste in the password. We get just the flag. And if we really wanted to, we could add this to a script, right? Grab this, make a directory. What was this challenge called? Super SSH. And then cd into that directory and make a file called getflag.sh. Then bash. Paste that in, and then if we really wanted to, we could leave a comment to denote what the password is. Password is this. Save and exit. Now make it executable. Now we can run it, slam in the password, and then it prints out the flag. So that's cool, just a neat little way to write like some bash code. And I did make my background fully black again, having it transparent. It was kind of throwing me off. It looked a little bit ugly. I know some people are into that so they can see like their background image and whatnot, but I think it is a little bit distracting, especially for these videos. So with all that talking out the way, I'm going to grab this flag, come back here and slam it into the prompt. Nice. Let's look at commitment issues. The next challenge, which is a very interesting name. The description is, I accidentally wrote the flag down. Good thing I deleted it. You download the challenge files here. So let's right click this, copy this link, go back to our terminal. This time, let's make a new directory. I am going to enter the bash shell because one feature of Z shell is that it auto completes your commands. It's kind of distracting. It's getting in the way. Let's see if I can change my prompt at all. Okay, so there's a variable being set called prompt alternative, and that is set to 2 lines. Right here, 2 line. Let's change that to 1 line. Save and exit. I might need to restart this. Reset. Source. Bash rc. There we go. I prefer just a single line. I don't really like that 2 line that we saw earlier up here where it makes everything on a separate line. I prefer this. So all I did was edit my bash rc file, and there was a variable called prompt_alternative. Change that from 2 line to 1 line. Sweet. So now let's make a directory. Commitment issues. And then cd into that. Now we can download this file, challenge.zip, that downloaded successfully. It is a zip file. It is kind of big. Let's unzip it. Oh, that had a lot of junk in it. We see a .git, so we know they use some type of version control. Get branches, get description, get hooks, get info, get head, get objects, get logs, and then we see message.txt. Let's remove that zip file just to make it a little bit more clean. cd into this directory. Let's open up messages.txt. It simply says top secret. It's not too helpful there. Let's go into the Git directory. Do we see anything there that's useful? Branches, commit, maybe the logs. Can I just run git log? So git log, let's look at the previous commit history. So commit, okay, Saturday, March 9th, remove sensitive info, and then right here, create flag. So it seems like the first commit was they created the flag, and then they removed that sensitive info. So can we revert this to this previous commit? Let's look up the manual page for Git. Git, the stupid content tracker. Git is a fast, scalable, distributed revision control system with an unusually rich command set that provides both high-level operations and full access to internals. All that's saying is it's using version control, so you can create, separate pull requests, separate branches, even different forks of a source code repository, and it saves your changes for you remotely, basically in the cloud on a site like GitHub or GitLab. So if you do make a mistake, you can always revert back to a previous saved version. So let's see what kind of commands we have to work with. We can look at this, git diff, show changes between commits. Let's look at that. Let's look at man git diff. How do we do that? Show changes between commits. We know this repo has 2 commits created to it, and we want that first one. What if I just run git diff? Nothing. Git commit. No, that's not what I want. Git log. Git diff. Do I need to specify the 2 things I want to diff? There we go. Git diff. Now look at the original commit, the first commit that was created, like this hash, this value, and then it prints out the flag. We see here A and B, we see minus and we see plus. So this is just saying originally messages.txt had the flag inside of it, and then it got deleted and overwritten with top secret. So if I cat messages, it is top secret. This was removed and then this was added. So that's pretty cool. So now we can come here and slam in that flag. And hey, since we're talking about GitHub, I do have one of my own, github.com/Jason Turley. So if we go there, we can check it out. I do have a couple repositories, some code and some tidbits and some cheat sheets and things I've been working on. So if you're curious about like learning data structures, I do have those implemented in C, C++, and Python. Some previous capture flag solutions if you're doing the EJBT, the eLearn Security Junior Penetration and Testing course. I do have some notes when I took that a few years ago, and there's a miscellaneous other repositories of different programming languages and code, whatnot. A lot of failed projects, a lot of stuff I started and never finalized or finished, right? We see this one was over 2 years ago, and I was trying to make a rootkit in Linux, and I kind of just gave up. But I did make a little bit of progress. So yeah, check it out if you care. If not, no big deal. So let's come back. Let's do one more. I think we're rolling along. We're cruising. Let's see if we can knock out one more challenge. Time machine. What was I last working on? I remember writing a note to help me remember. You can download the files here. And once again, there is a zip file. So let's right click and copy this link. You can come over here. Before we move on, we could make a little git flag script just to note how we did this. So let's save. Let's back up here. Vim git flag .sh. Once again, bin bash. We ran git log, and then we did git diff. And if we really wanted, we could try to cut or just grep out picoCTF. Let's see if that works. Bash git flag. Ooh, you do not like that. Oh, it wants this to be run from this directory, because this is where the git directory is, right? Move git flag to drop cd there. Now if I do it bash git flag, it does print out just a flag, and we can be cute and we can be silly with the cut command. Very useful. Cut eliminator, make that the minus sign, and grab the second field, save and exit. Now when we run bash, it gets just that flag. So if I cat it out one more time, this is what we did. We were in git diff on this commit, we grepped out our flag, and then we did cut. So if you ever come back to this challenge like a month from now and you forgot how you solved it, it's kind of nice to have a note and a log of how you did it. So once again, time machine, grab this. Let's make a new directory. cd into it. And let's download our challenge file. That was a success. Now we can unzip it. Sweet. We can already see just from the output that this once again has a .git file, meaning it is a Git version control. It is a Git repository. Did I grab the wrong thing? This says drop in. It's the same thing as before. Time machine. Commitment issues. Maybe not. Maybe they just really love making Git repositories. Okay, cd into drop in. Okay, so this is different. This message.txt does contain something different. This time it says, this is what I was working on, but I need to look at my commit history to know why. Is this similar to the last challenge? Can I just do a git log? Git log, and then there's the flag. So they're really loving Git. I don't know if there's any kind of miscommunication between the challenge authors or the challenge creators, but running git log was not too bad. I'm not going to do the whole git flag script, but as you know, you could easily just git log and then grep out picoCTF, and there you get the flag. If you want, you can add in that curly brace just to get this one. Sweet. Not too shabby, not too shabby at all. Let's look at the blame game. Someone's commits seem to be preventing the program from working. Who is it? And then once again, download the challenge.zip. You see how this gets pretty repetitive pretty quickly, but that's okay. If you've never used the command line, if you've never used a shell, this is very good practice for making directories and changing directories and navigating. Using wget to download files, this is some pretty good practice. And that's all we really care about. Okay, so this is also a Git repo. It's very big. We can see there's a lot of commits. There's a lot of objects in here. So ls, we can remove the challenge.zip just because we don't need it anymore. Navigate to drop in. And yep. So there's another message file, but this time it is a Python script. So let's, I don't know if I want to cat it out. Let's open it up in view. Oh, it just simply says print hello world. It's one singular line. I'm not even sure if this would work. We see that there's no closing parentheses. So if we really wanted to, we could run this with Python 3 and the message.py, and it does give us an error. So if you've never used Python, if you've never written any code or run any Python code, let's debug this error. So it just tells us what file it found the error in, messages.py, and then it gives us the exact line number 1. There's only one line in the file anyway. It tries to print something out, but says, hey, this parentheses, this opening brace, it was never closed. So I don't think this is the challenge, or this is the way to solve the challenge. But if we really wanted to, we could open up messages.py and just close that parentheses out. Control R to reverse search. Now we run Python on that script. It does print it out just fine. Let's once again run a git log, look at the different commits that were made. We see that it's a lot, right? If you can kind of see here in the bottom, there's this colon right here. This is because I am in my system pager. It tried to open everything up, but the file is too big to fit on one screen, like one page on my screen. So it opened it up in my default pager. That happens to be less for me. Let's see if we can check that out in the environment variable. Env grep page. Env less. I don't know if it's set here or where exactly it gets set, but my pager is less. There's also more, which usually is just a symbolic link to less. Anyway, I'm getting off topic. So all this is doing is opening this up in a nice output for me, and then you can hit the space bar or page down and page up to navigate through this. You can do some cool tricks, right? G goes to the top of the line, capital G goes to the bottom. Now you can see that it says end because I hit capital G. So let's hit single lowercase g to go to the top. You could also do searches. So I can search for flag, nothing. I can search for an opening curly brace, nothing. So let's just read through this stuff. So the most recent commit, right, March 9th at this timestamp, important business work, important business work, important business work. Oh, do they all just say important business work? That's interesting. Yeah, maybe there's one that won't say important business work. Here we go. When we go all the way to the bottom, create top secret project, optimize files of production code. Interesting. So these two commits, oh, right here, we can see the author. The author is just the flag, picoCTF, ask the intern. So how could we have found this without running git log and just searching through? Someone's commits seem to be preventing the program from working. Who is it? What do the hints say? In collaborative projects, many users can make many changes. How can you see the changes within one file? Read the chapter on Git from picoprimer here. So maybe we want to open that up as well and peruse that. You can use Python 3 file.py to try running the code. You won't need this for the challenge. So we already did that. So let's see, can I do git log and then grep author? You do not like that. Man, git log. This is interesting. So git log has a command that has a flag for author. Limit the commit output to one with this author. Then you can give it a pattern. Let's give that a shot. Git log tac author equals, and then we just want to give it a pattern, pico. They all have pico in them. picoCTF, and then opening curly brace. That works. I wonder if this lets us do a star. No, it doesn't like that. So that's one way to do it. And then from here, I'm sure you could run grep. And then from there, you can do cut, delineate on the colon, specify the second field. We get a little extra, so now let's do another cut and delineate on a space, and then just grab that first field. Ooh, you don't like that at all. Instead of a space, oh, because there's a space right here, space right here. So let's do something else. Let's delineate on that less than sign. There we go. So whoever is creating these challenges, they really do enjoy Git. They really like that version control system. So that was kind of neat. And the rest of these, collaborative development, I have a feeling this is another Git one. Yeah, challenge.zip, peeking at the hints, Git branch stack A, okie dokie. Just for completion's sake, let's knock this one out. We're already talking about Git so much. I feel like this is a good one to end it on. So let's once again make a new directory. What was this called? Collaborative development. Now let's cd into that directory and download the challenge file. Let's unzip it and then remove the challenge file because we don't need it. lsec-l, drop in lsec-la. There's a flag.py. Oh, it really doesn't do anything. It just says printing the flag. You can run it in Python just for jokes, printing the flag. And we once again see the git, the .git file. Let's do a git log. There's only one commit, init flag printer. And then there's something for the main branch. We already kind of cheated. Well, cheating's not the right word. We already peeked at the hint. Git branch.a will let you see all of the available branches. So let's look at the man page for git branch. List, create, or delete branches. So what is a branch in version control? What is a branch in Git or GitHub? So you have the main project, and then you can create separate branches or forks or routes. Basically, just think of it like a family tree. You have the main branch, and then it kind of splits off in other sub branches as well. And this is very useful because perhaps you just want to test something, you want to test a feature, you want to add maybe different color schemes, but you don't want to push it to the main production system. So this is where having a branch comes in handy. You can make a separate test essentially and do all your features and additions there. And if anything goes wrong, it doesn't matter. You didn't actually interact with the main branch in any way whatsoever. And once you're finished with that sub branch, you created that feature, you can just merge them together into one. And it's telling us here, we can do a tag list to see all the branches that are there. So let's do a git branch. So just like I said, there are some features, part 1, 2, and 3, and we see the main has a star and it's nice and color coded. So if I do a git branch tag list, it'll give me the same information. And if I do a git branch tag a, once again the same information, just multiple ways to get the same output. Let me switch over to a branch, and I can do that by just specifying the branch name. No, that's not correct. How do I switch branches? Man git branch. I sound like a caveman. Man git branch. Okay, here we go. So I looked at the man page for Git, and there is a Git checkout option, and this allows you to switch branches. So the Git branch section of commands, Git branch, all this does is let you list, create, or delete branches. But if you actually want to switch branches, you need to use the Git checkout sub menu or sub function, whatever you want to call it. Switch branches or restore working trees. Cool. So let's do git checkout. I don't want that hyphen there. Git checkout, and let's just grab this first one. Now if I do an ls, there is a flag.py. Ooh. So I can print that out. And we get the beginning of the flag, picoCTF teamwork. Okay. If I wanted to, I could grab that and throw that into like a little text document. Ignore that. If we want, we can run this with Python. And it just prints out the beginning of the flag. Now let's switch branches to part 2. I'm guessing we're gonna have the same thing where we can just run Python on this little flag chunk and we get the rest of the flag, or at least the next piece of the puzzle. And now do the same thing for that third branch, and once again print out the flag. And we get the full piece. picoCTF, teamwork makes the dream work, and that is very true. Come here, slam it in, smash enter, And we are done. I think that was the end of the Git challenges. That was like maybe 4 in a row. Not really what I was expecting, and that is a lot. But if you've never used GitHub before, I do encourage you to check out the picoCTF primer that they have on Git and version control. Everything picoCTF and the folks behind there put out is top-notch quality. And if you do want to make a GitHub, it is very free and easy to set up. You can use mine as an example, as a template, but yeah, pretty fun technical stuff. So the next one, bin hexa. How well can you perform basic binary operations? Additional details will be available after you launch this instance. Maybe I'll save that for a teaser for next time we see some on binary search, Indianness, Don't You Love Banners, and Sans Alpha. So I think I'll end this video there. It is getting a bit long. Thanks for bearing with me, guys. I know it's been a while. It's good to be back in the saddle, making these kind of capture the flag videos. Let me know how you guys solve these challenges or anything I'm missing out on. Any tips, tricks, or advice, leave them in the comments below. As always, take it easy and see you guys in the next video.